Now moving along to problem 59, we notice that in this trinomial there's a 2 common. All these are even, so there's a 2 common, and also there's an x common, right? I got 3 here, 2 here, and 1 here. So let's start this one by factoring out this 2x, and if we do that, what we're going to be left with is an x squared, right? We had a 2x cubed, we removed the 2, and there were 3 x's, we removed 1, so there's only 2 left. Then, plus 5x, right? 2 times what will give us 10, so do a division. 10 divided by 2 is the 5. There were 2 x's, we removed 1, so there's 1 left. And then finally, plus 4. Now, let's see if we can factor this one here. Let's bring the 2x down, don't forget that. Write our 2 sets of parentheses. We've got x and x, and now we can do this one. What factors of 4 will give us a 5 when we add them together? Well, 2 and 2 is not going to work, but 4 and 1, I can get a 5 out of that. So I'm going to put a 4 here and a 1 here, or if you like, you could put a 1 here and a 4 here. Order doesn't matter because it's multiplication, which is commutative. This 4 is positive. So these two numbers have the same sign, and that's going to be that middle plus sign. So we're going to write x plus 4, x plus 1, and there is our factored form. Let's go on to 61. Now we notice in 61, as in 59, right? In 59 we had something common all the way through. We have something common all the way through here. There's a 2 common, so let's take a 2 out. And look at these k's. We've got 6 of them here, 5 here, and 4 here. There's at least 4 k's in each one of these terms. Remember, it's always, the one you factor out is always the one with the smallest exponent. So we're going to take out a 2k to the 4th. And we're left with k squared plus 11k minus 26. Let's be sure we know where these numbers are coming from. We had a 2k to the 6th, we removed the 2, so the 2's gone. We had 6k's, we removed 4, so there's only 2 left. Now 22 divided by 2 is, there's the 11, right? 2 times 11 is a 22. We had 5k's, we removed 4, so there's 1 left. And then 2 times what is negative 52? Well, our division, negative 52 divided by 2 gives us negative 26. We had 4k's, we removed all 4. So now, let's see if we can factor this trinomial. So bring down that 2k to the 4th. We don't want to forget that. And our 2 parentheses started off with a k and a k. Now, this 26 here, we can use a 26 and a 1. Now, a 26 and a 1, if we add those, we'll get 27. If we subtract them, we get 25. That's not going to give us our 11. Cut in half and double, we'll get 13 and 2, and I think that's going to be it. 13 and 2, I can get an 11 out of that. So I'm going to put in right here a 13 and over here a 2, and again the order doesn't matter. I could put the 2 here and the 13 here. This last term is negative, so these two numbers have opposite signs. I'll put that middle plus sign with the bigger of the 2 products, so I'm going to put it here. Plus 13 minus 2 is plus 11, and you can check if you like, but I think we've got it. There is our factored form. Number 69, we have some x's in common, right? I got 5 here, 4 here, 3 here, but I don't have y's in common. I've got no y's here, 1 here, and 2 here. So we can at least factor out, now what about x's we're going to factor out? The one with the smallest exponent. We've got 3 x's here, 4 here, 5 here. So there's at least 3 x's in each one. So let's take out an x cubed, and if we do that, we're left with x squared plus 14xy minus 15y squared. Now let's see what we can do about factoring this one. X cubed, there's our parentheses, about x and x, and now the factors of 15, that'll give us a 14. Well, 15 and 1 is going to work. 5 and 3, it's not going to work. I can't get a 14 out of 5 and a 3. But I've got that y squared, so let's be careful here. So I'm going to put a 15y and a y. And now because this 15 is negative, these numbers have to have opposite signs. These have to have opposite signs. So I'll put that middle plus sign with the larger of the two products. Here's my inner product. That's 15xy. That's bigger than the outer. It's only 1xy. So I'm going to put the plus here, plus 15xy minus xy. And there we go. Our factored form. Let's move on here to number 71. Notice what we've got here. We've got 9 z's here, 8 of them here, 7 of them here. So there's at least 7 z's in common. But there's no y's in common. I got 2 here, 1 here, but none here. So we can at least take out those 7 z's. So we'll get a z to the 7th. And then what's left here? Well, we started with 9 z's and we took out 7. So there's 2 left. Plus, now in this term here, there was a 3, 8 z's and a y. We took out 7 z's. So what's left is still that 3, a z and a y, and then minus 54. Now there were 7 z's, but we removed all of them, so no z's left there, but a y squared. Now let's see what we can do about factoring this trinomial. So we'll get that z to the 7th. Don't forget to bring that down. And then we're going to get a z and a z. Now I'm looking for the factors of 54 that are going to give us a 1. So 54 we could write as 54 and 1. That doesn't help. Cut in half and double. 27 and 2. That's not going to work. Now that 27, this is not even, so I can't easily cut it in half. But it is divisible by 9. So I'll divide it by 9. And then if I divide this by 9, I'll multiply this by 9. So if I divide by 9, I get 3 and 18. Now that's not going to work. Now that 18, that's even, so I'm going to cut in half and double. So how about 9 and 6? 9 and 6, I can get a 3 out of that. So let's try that. Let's come up here and we use a 9, but we have to get that y, right? What we've got out here is we've got a y squared, so we need to account for the y. And a 6y. So this 54 is negative, so these two numbers have opposite signs. I'm going to put that middle plus sign with the bigger of the two products, and the way I wrote mine is the 9yz is bigger than the 6yz. So here's 9 minus 6 is the plus 3, and I'm going to claim now that that is the correct factored form.